Thank you, Mr. Singh, for that nice opening address. Ravitej, my old friend, Anand, Hemant, and all the other dignitaries for this first digital conference that you're holding. It's already started up on schedule, which is a very nice thing to have, especially given time differences. And I really look forward to participating in many of the serious dialogues that Mr. Singh highlighted. One of the things that is a bit of a puzzle for me, as I'll go to my main topic, which is refinery of the future, is this lack of diesel consumption in India, which is very surprising because when I look at my own country here in the US, diesel prices are stubbornly high, and that is driven by all the trucks going across the country. Either it is produce or Amazon trucks or that infrastructure. And I've seen this in the US. Western Europe obviously was very high before the EV started chewing up that market. But more importantly, in China, right now they don't want to make a drop more of diesel because they have so much of diesel. But prior to that, the growth in consumption based, and it was all tied to the infrastructure, the massive road systems. And I'm sure that once India gets this, let's say, big interstates working like in other places, the diesel consumption is again going to bounce back because there's no way the railways are going to catch up in terms of timing with the demand from the consumers. Gasoline is, yes, it is there because of the cars and currently, but as the middle class grows in India dramatically, there has to be a big supply of people, the goods moving back and forth. So that's a dialogue I would like to have, because when I look at trends and how it has moved even in the US, it is being driven by trucks from city to city and hub to hub. Anyway, what I'll do is, let me just see. Can you see the screen?
Yeah, it's visible.
Okay, good. So what I'd like to do is, over the next 20 minutes or so, take you for the refinery of the future. And surprisingly, this is a topic that I addressed in the Middle East and even in India about 10 years ago in 2013. And just to have a viewpoint on where are we, in those days, we would eliminate fuel oil and any other low value streams, liquid fuel maximization, in particular diesel, lube oil base stocks, and capability to shift product demands. Have a very high Nelson complexity index. Look at Reliance. I think its complexity index is something like 21, which permits you to shift between different products. Capability to produce high propylene, high value aromatics, and adjacent to petrochemicals, as Mr. Singh noted, that petrochemicals will keep growing. And flexibility to process opportunity crudes. Now, in the last several years, what has happened is the opportunity crudes, the heavy ones, no one is interested anymore. The Venezuelans, Mayans, Arab heavy, there's so much of the lighter crudes, like the Arab extra light, currently available, that those heavy ones, the opportunity crudes, have shifted to West African and the lighter, sweeter crudes from other places, till such time as demand catches up again. And the energy intensity index of less than 70, that still holds. And the capability to blend about 10% of biofuels. This was back in 2013. So if I go forward, I just wanted to have a look at what is going on around the world in terms of refining activity, because If I start from the bottom, which is North America, there's nothing going on in refining other than keeping the refineries going. A lot of excess capacity is being shed. Many refineries, I think last year in 2020, about 7 of them shut down. Some of the ones that have been shut down are converting to renewables, especially people like PBF. They are converting. Consolidation, you must have read the rumor, still a rumor, but who knows what's going on, that the consolidation of including people like Chevron and Exxon talking, right? So there's no restriction to the amount of, or let's say the size of companies willing to consolidate, but that so far has been treated as a rumor. Central and South America, Pemex is showing some signs of life. South America, other than Colombia, is pretty dead. Africa, there is activity. Nigeria, Ethiopia, Ghana, Kenya, West Africa, some activity, mostly in transportation fuels. Europe, completely, western side of Europe is very, very slow, including stopping existing projects that were announced in FEED and EPC. Some of them are stopping. Eastern Europe is still focused on diesel, places like Serbia, Croatia. If you move a little further west, they don't want any more diesel. They're moving on to petrochemicals. South Korea, big market, revamps, and again, a focus on petrochemicals more so than transportation fuels. In fact, the large refineries like SK, GS, S-Oil, they're looking at moving to convert from 10% all the way up to about 50% chemicals if possible. Singapore, they keep on planning one large complex. It's still the biggest trading hubs. A lot of products are moving through it, but I have not seen any action from 2013 to now in terms of actual projects. On the other hand, Thailand, they are building. There are projects going on. Vietnam they have one large project. Malaysia is building. And Indonesia is doing it very slowly, but they are planning some big mega complexes. Russia, between Rosneft, Gazprom Neft, Lukoil, Tatneft, there are projects mostly focused on petrochemicals and diesel and conversion of their enormous quantities of mazout, which is the fuel oil, back to transportation fuels. They have a lot of natural gas, so hydrogen is relatively cheap, but those things are going on. Now, the big driver in everything has been China. And this is something that we can learn everywhere else in the world. If you look at the complexes in ZPC, one of the biggest complexes I've seen in recent times, or Hengli, the speed at which they build is unbelievable. Within 3.5 years from the basic engineering packages being completed to steel on the ground, and within about 4 years, everything is starting up. Things like that are giving them a huge edge, so much so that people like South Korea are worried about the enormous quantities of all kinds of polymers that is coming from China. So especially the private sector, ZPC, Hengli, Shenhong, Huajin, Nanshan, and Hengyi, these are the big players, and they are building extremely fast. Now, I was very, very proud of the speed at which companies like L&T are building these heavy wall reactors and other large equipment. So yes, we can do it, but we have to get to that kind of speed, 3 to 4 years concept to commissioning, if we are to compete against it. And then in Middle East last year saw a massive slowdown from the pace at which they were going. many of the projects, they took a breather as they saw the oil prices drop dramatically. If you recall, one day the oil price had gone negative in the US. Negative, that means people would pay you to take oil from the hub in Texas or Oklahoma. So, but now oil prices have recovered. They're around $60 a barrel. So again, some of the projects have started back up, including projects in United Arab Emirates and Saudi Arabia. So globally, you see, most of the action is happening in the eastern side, Middle East, India, China, and Russia, Indonesia, Malaysia. The West is pretty, they're just maintaining their tier 3 gasoline and continuing because they know that there's enough fuel available elsewhere. So what are the current growth? What is driving the refineries? When we talk of the future, if you see in Middle East and India, it takes between 5 and 7 years to get to that place. So when we talk of the future, we are not talking of, we are talking close to 2028, 2030. So the number of residue upgrading projects, they're growing at about 3 times the rate of new refineries. Each of those projects required hydrocracking. Migration to premium lubricants will continue. A persistent demand for delayed coking from Eastern Europe and Russia. RDS, RFCC, some mega projects are being planned. And especially in the context that Mr. Singh highlighted, that if there's a gasoline demand, then the RFCC still remains extremely attractive. What we have to do is to get that net conversion from crude up. So that's part of the driving force for the RDS RFCC projects. So major challenges, I checked this week, the VLSFO price is about $510, $508 a ton, whether it's Rotterdam and Singapore, there's a slight difference. And the delta between VLSFO and HSFO is about $200 a ton. So a 20,400,000 barrel per day refinery, you're losing about $1 billion a year in opportunity cost if you're not doing anything with your fuel oil. And that's one of the major drivers wherever we see, whether it's an RDS, RFCC, or a resid hydrocracking or a delayed coking. If you go to the lighter, sweeter crudes, as some people are doing in Europe, to minimize the bottoms, then you're paying more for that crude. Blending is extremely expensive because now you're taking away low sulfur VGO or a diesel, essentially, and blending it with the high sulfur fuel oil to make your less than 0.5% sulfur fuel oil. So it's a huge opportunity cost if you're not doing anything, especially with the Middle Eastern crudes. And if you switch to a much lighter crude, then that percentage drops, but still it's a loss. And that's one of the drivers. So there are lots of LC Max, LC LSFO, LC slurry. There are lots of techniques available to convert the resid. The study converts almost everything that is there. Yes, there are capex, but as companies in India are capable of building most of these equipment that are involved, we see the capex coming down. Like I was really encouraged with NRL building a new LC fining unit. So if I took the cost of building that LC fining in, let's say, Portugal versus in Assam, there's a huge capex advantage of building in India, despite the lower, let's say, labor productivity. Just the absolute cost of building is less. So if you have to convert everything, these LC platforms give you away. This one has seen a lot of attraction where taking advantage of the VLSFO price, we can do a partial conversion of resid and make very high quality VLSFO. What this does is it permits you to get a lot of the FCC slurry oil also converted, which is a challenge for many refiners. Something to think about. And then the slurry, we are investing a lot, working closely with many people. And this is a complete conversion of bottoms. It's a very unique catalyst system, which traps all the metals and carbon inside those pores. So if you go to a true zero residue solution, this is something to consider. So between coking, RDS, LC firing, LC max, LC, I've just presented progressively as you go to the right, you get from every barrel of residue, complete conversion. Yes, there'll be hydrogen because your vacuum resid has got low hydrogen, and as you go towards the right, especially if your slate is going more towards LPG and naphtha, there will be more hydrogen. What has happened is that the cost of natural gas is also trending lower as more and more supplies come on stream from Qatar and Australia, India, but especially, and of course, the LNG exports from the US, we see that the price of natural gas is trending lower, even in places where it traditionally was very high, South Korea, Japan, Northern China. These things start making sense as we secure the hydrogen. Yes, because if I take on the right-hand side, LPG, naphtha, they have a huge hydrogen content compared to the starting resid. So we have to secure the hydrogen. So this is what a post 2020 complex would look like. You know, you have the FCC, a cat feed hydrotreater, hydrocracker, because that's what is balancing between kerosene and gasoline. And you are taking your ROG, refinery of gases, and other light naphtha to the cracker. And in the bottoms, you can make very low sulfur fuel oil and FCC feed. So this represents a pretty tight complex of today. So this forms like a baseline from which to look at the future. So the trends that we are seeing worldwide are in terms of dollars per ton. If I take the crude cost and I put it on the same scale, yes, ethylene, propylene, ethylene from gas crackers, the price is much lower than propylene in the US, for example. But in other places, they are closer to each other. You have got paraxylene and then gasoline, diesel, and very low sulfur fuel oil. And then what is being pushed out are the heavy fuel oil and coke. So what are the disruptive forces that we are finding? Mr. Singh mentioned something about electric vehicles. Yes, the pandemic was a huge shock, but I think that's temporary. Again, we'll bounce back. The shale gas in the US, that has brought down the cost of natural gas, and LNG is being exported from the US to the Far East. So yes, that has the shale oil part of it is very strange because yes, they turned it on, but last year, as you know, the many companies went into bankruptcy as the oil prices fell. So, but the Middle East and the OPEC is always paying very close attention to the number of rigs in operation in Texas and Oklahoma. The one thing that is very fast growing and which will put tremendous pressure on infrastructure are the, believe it or not, Bitcoins and data centers. I was amazed to learn that Bitcoins in 2019 consumed more power, 123 terawatt hours, which is more than the consumption of Pakistan as a country, just to make those Bitcoins, to mine those Bitcoins. Data centers, very, very fast growing data centers throughout the US, Western Europe, India, I'm sure. A huge consumer of power. A lot of it is being planned as renewables, but uh, uh, at the end of the day, well, whether it's an EV or data center or a Bitcoin, you're still somehow you're putting a pressure on the natural power grid system. And that's why I agree with Mr. Singh's assumption that fossil fuels will remain very, very relevant, not just up to 2035, but beyond, as there's tremendous pressure on the supplying to other than your normal consumers, because the normal consumers like you and I will need all the stuff that we are buying, and that would put pressure on the data centers, which will chew up more electricity. And there's only so much of natural gas supply. So naphtha becomes increasingly important going forward, and the crude conversion becomes extremely important. So what is driving growth? If I see the petrochemicals demand is growing, whichever region I look, at maybe 3 times the clip of fossil fuels, maybe higher sometimes. And that's been driven by the global middle class growth. 2015, 3 billion middle class. In 2030, we are talking of 5.5 billion. So they are the real drivers of this growth: rising GDP, rising middle class, and the unprecedented growth in Asia Pacific. And believe it or not, Africa is going to become very significant post 2040. So this is a nice chart which shows that what is coming, product flexibility from crude derived liquids. You have got naphtha, you've got gas derived, and you've got oil derived. And if you see, the oil derived is still a pretty significant part. And then I've also got from methanol, which is growing, but still a very small fragment. So almost 60% crude derived liquids is needed to make those petrochemicals growth. Now, just like everywhere else, conversion of crude to chemicals is by its very nature green, because what happens is now you're trapping the carbon in the form of plastics. Now, many of these plastics, by law in certain countries, other places are catching up, are being recycled. So instead of just going to CO2 and greenhouse gases, conversion of crude to plastics is by its very nature green. And there's a big push to convert more barrels of crude towards the plastics, especially in the oil producing countries such as Saudi Arabia, and not just Saudi Arabia, the entire GCC, in China, and in places like South Korea. So if I take what has gone on 2020 and beyond, we are looking at 40 to 80% of chemicals as a target. Right now, we are still much, much lower than even 40% in most refineries. It's still probably less than 15% stuck there because of lack of investment. But if I look at place like the new refineries that have come up in China, they're already in the 2020 and beyond range in terms of total amount of chemicals. So that's a good target to have. Now, how do I reach that target? So about 2 years ago, Chevron, Lummus Global, and Aramco embarked on a very intense program to convert all the molecules from a molecular level, convert those molecules that exist back to petrochemicals with the minimum amount of capital and minimum amount of energy. So the target was at least 70% chemicals, and it had to be at least 40% cheaper than typical crude oil to chemical routing using conventional route. So, sorry. So what it does is it takes the crude, and we tested it on Arab Extra Light, Arab Light, and Arab Medium. The intense program was first tried out on Arab Light and Arab Extra Light. What it does is it takes the crude. There's no crude at vacuum distillation. Some of the crude is taken to a special separation device. Part of it is sent directly to the mixed feed cracker, and anything that is heavy is hydroprocessed not to naphtha or LPG, but just enough so that the cracker can then accept it without the contaminants and with the right amount of hydrogen. You can trap aromatics from the system if you have a need for aromatics, or you can just have the mixed feed cracker embedded with what we call crude conditioning. So it's a very compact system. The first one was commercialized in a refinery in Asia. So, and there are at least 2 planned in the next couple of years, including one potentially in India. So you can bring in the crude. You don't have to have crude vacuum distillation. You need some fixed bed hydroprocessing, and you need, if the crude is heavy, then you need a little bit of hammer, like an ablated bed reactor or a slurry reactor, to convert it back to the fixed bed system. But these are not complete units. These are portions of proven technologies that have been fitted together such that you only take the equipment that is an absolute necessity in order to convert a particular molecule. You never have that fractionation and entire separation systems, because those are common. So what are we looking at? For a 1500 KTA ethylene plant, we are looking at about 100,000 barrels per day of Arab Light crude. So that's pretty efficient. And along with that ethylene, you get propylene, butadiene, aromatics. So if the intent is to make chemicals from crude, this is a very good way. We are looking at between 70 and 80% chemicals from crude. And why is it attractive? Because when we make petrochemicals, we always look at the ethylene cost curve. How much does it cost to make ethylene based on a particular feedstock? And if I look at the spread between naphtha and crude, it is keeping on rising from $150, $100 roughly to over $160 by the time after 2030. The other thing that can happen is you can take all the low value streams, pyrolysis fuel oil from your mixed feed cracker, or slurry oil from your FCC unit, or pitch. And you can vary the ethylene to propylene ratio. So once you start processing crude, be it Arab Extra Light or Arab Light or Permian, you get a tremendous amount of flexibility. The other thing that is always there is with this system, you can always make diesel or gasoline on demand. So you don't have to convert everything to chemicals, but it gives you an ability to make very high quality diesel, very low sulfur fuel oil, or gasoline on demand. So this truly disruptive, as I said, 30 to 40% less capex and 70 to 80% chemicals from most crude. And it can be a plug-on. If you have existing refineries like BPCL, Reliance, SR, you can just take a portion of the crude and convert that to chemicals, while you, as Mr. Singh mentioned, that there is the belly that is less valuable. There is no reason why you can't take some of that belly and convert that into chemicals very readily, because that belly is already lighter than the whole crude. Or you take some of your crude and convert that to chemicals, while the rest of the refinery is focused on making more gasoline. So there are some very interesting solutions which are called bolt-on solutions, which especially the Kingdom of Saudi Arabia is looking at, where they have excess diesel or excess, in certain instances, that they don't want jet, they don't want diesel, they want more of the chemicals. This is one way to do it. So the IMO 2020 was a big driver. We have addressed it with many technologies, innovative solution, crude to chemicals, expanding conventional technology. India still doesn't have an RDS unit. Other places do. Whenever you have an RFCC, that's a very good option. And sustainable technologies. As we go around the world, even in places like Indonesia, China, Thailand, they're looking at some amount of biofuels into the feed. Premium lubricants and white oils, both these are low-hanging fruit available to refiners, and this market is pretty robust. India still imports a lot of the lube oils, something to consider. BPCL, of course, is a big producer, but for most refiners, this is a very quick, low-cost way of getting some real benefits from every barrel of unconverted oil. Biofuels, lots of things going on in the US and other places. Now, biofuels, there are some big challenges in the sense that if I take non-edible plants, the amount of acreage per barrel of biofuel is enormous. It doesn't become sustainable. So we always look at what else is there, waste oils, or ideally, if I can consume waste plastics and biofuels together, it starts making sense in terms of scale. So we commercialized one of the units in Japan with different types of feeds, but certainly diesel, jet fuel, naphtha. There are planes that have flown with our ready jet and ready diesel. These technologies are already available. Some of them are without the use of hydrogen, using supercritical water. So something to look at. But again, these are small, relatively small plants compared to the scale that is needed. But what has happened is, especially places like Northern Europe, unless I have at least 10% of the feed going into, along with the fossil fuel, that project will not get sanctioned. Now that number is going to creep up, some cases all the way up to 100% of biofeeds, but at the moment it's between 10 and 30%. Plastic recycling, we started a new venture in Texas with a company called New Hope, where we take plastic waste, different kinds of plastics. If I had only polypropylene or polyethylene, life becomes very easy because those are easiest to convert back to petrochemical feedstocks. But sometimes you get nylons, you get things that have different structures, lots and lots of chlorine. But the processes are available now today to convert plastics back into either fossil fuels or transportation fuels or into petrochemical feedstock, and using either the FCC platform or fixed bed hydrocracking platforms. Digitalization. This is again with Lummus Digital. This one, unlike other efforts, what we have focused on is that every digitalization application has to have real dollars behind it in terms of what is it that the refinery gains by putting that particular digitalization operation at the refinery. So our first trial of this, is at a refinery in one of the Aramco systems. The platform itself is running in Haldia Petrochemicals for a while on an naphtha cracker, but it is again focused on margins and profitability increase, because without it, I have, at least in the 30 years plus that I've been in this system, yes, it's very good to look at, but what are we gaining? It has to be either you extend your catalyst run length, but more importantly, you maximize yield per unit of feed, and that's been the focus. Training centers, as more and more of our technical staff are retiring, leaving our industry, this has also become vital, that how do I pass the knowledge from the Ravi Tejas of today to down the chain and make sure that we get the same amount of productivity going on. So how do I capture all the knowledge that is trapped in our heads in a very efficient digital format, which can be accessed, and then use that to train operators in different remote locations. So we call these the centers of excellence. The first one started up in Bahrain. We are starting up another one in Jubail. And this will train young and experienced operators in all aspects, from normal operations to even fundamentals to how to deal with emergency situations. The other thing that we are working on, and extremely important for the refinery of the future, are these, we used to have these 3D models. Now these are live 3D models where you're walking through complex plants, be it LC fining or a cracker. And this is by far one of the best ways to teach the new staff of what it is, where the valves are they accessible, where are the emergency systems, how do I get to them, is the access good, where will the trucks come in, all those things, right? Using these digital platforms, we are working with a company called Explain Media to develop this for some of our complex portfolios. So refinery of the future, consider direct conversion of crude to chemicals. Existing bolt-on crude to chemicals is something that you can consider. I would say that about 50% petrochemicals is a good target to go up and down, anywhere from 30 to 70. No orphan streams. We shouldn't have any slurry oil going to fuel oil, or even eventually no pitch, no coke. No pyrolysis fuel oil from the mixed feed cracker. And while we're designing the system, let us look forward and keep at least 10% of the biofeeds or plastics handling capability. We are also working very actively on our blue and green hydrogen technologies. So as we realize that more and more of the units will need hydrogen in order to process it for petrochemicals and CO2 capture. Both of these are a forefront of our R&D at the moment, and I would say within the next 3 years, you'll see some large plants come up. And digitalization to enhance margin, but most importantly, have these regular conversations with experts and know how to transfer the knowledge from the experts to your junior staff, because I see this huge pool of very, very experienced personnel leaving our industry in the next 5 to 6 years. And that is the scariest part. And I see this world over, not just here. So with that, that's the end of my talk, Mavis. And I hope you got a flavor of what it is to look at a refinery going forward.